Welcome back to Remote Sensing Applications using ArcGIS. In this session, we'll start with some MODIS Hotspot point data. And basically, the hotspot point data are derived from the MODIS thermal anomaly product, which for pixels that are burning get converted to points. So for example, here's a fire within this 1 kilometer pixel. So the center of that 1 kilometer pixel will become a point. Here's 2 fires burning within this 1 kilometer pixel. So the center of that 1 kilometer pixel becomes a point. Here's a large fire. So it's basically making all 4 pixels hot. So the center of those 4 pixels will become points. So that's what we'll start with, and there'll be hotspot point data from the Mississippi fire from August of 2013 near Big Delta. Okay, so we'll start with 346 points from the Mississippi fire, and we have a variety of fields. We have the brightness temperature from the pixel. We have the pixel size in the scan direction, so that's basically left to right, and the pixel size in the track direction, so that's basically going forward as the sensor moves in orbit. The acquisition date, the acquisition time, the satellite, so this was the MODIS sensor on board either Aqua or Terra, and then the confidence in terms of the MODIS thermal anomaly product, and then the fire radiative power value, and then the day. So the first thing we want to do is for each day, how many points are there? So we'll run the frequency tool on this field day to get a count by day of our hotspot points. So our input will be our Mississippi fire hotspots. Our output I'll just call frequencytable.dbf. And then the one field we're interested in is this day field, so we'll check that on, and then just OK. So we have some days where we have few lightning strikes and other day or few hotspots. And for these days, we can't use the geoprocessing tool Kernel Density because the sample size is so small. So what we'll do is for August 10th, 7th, and 17th, we'll simply create polygons as dissolved buffer around those few points. So that's the first thing we'll do is we'll select those points from August 7th, 10th, and 17th. So they're a sample size of 4, a sample size of 4, and a sample size of 2. So we'll do a definition query. So our definition query is the day in this set of choices, and our set of choices are enclosed in parentheses. So our set of choices, if we go to day, get unique values, we could select our unique values. And then if we go to symbology, under categories, show us all the unique values. So we have August 10th, 17th, and 7, and then just OK. So here's August 17th, here's August 10th, and here is August 7th. So then we'll buffer those points using the buffer tool and dissolve by day. Okay, so we're going to buffer those points that have been selected using the definition query, and I'll output them as hot polygons August 7th, 10th, and 17th. And each point originally came from a pixel approximately 1 kilometer by 1 kilometer. So my buffer unit will be half a kilometer. And then we'll dissolve based on a field, and the field will be for every different day, give us a different dissolved polygon, and then just OK. So here are the output buffer polygons. So here's a polygon representing the hot areas from August 7th. Here's the hot areas from August 10th. And here is the hot area from August 17th. Okay, so that takes care of the days when we have a small sample size for hotspots. So then what we'll do is change our definition query and get all the other hotspots where we had an adequate sample size of at least 10 hotspots. So if we go to definition query, okay, so here was our original definition query. So now we'll do the opposite. So we'll take the operator not So not in August 10th, August 7th, or August 17th, and verify, and then just OK. And zoom to layer, and then if we go to symbology, add all the unique values. So now we have all the unique values. So now we've got a cloud of points where each point day has a sample size above 10. So if we look at, we've got, for example, August 8th, a sample size above 10. Okay, so now what we're going to do is derive polygons for each day. So what we want to do is split our cloud of points into layers for each day. And what we'll do is we'll make a feature class for each day using the split tool. So what we need is a polygon that we're going to split with. So what we'll do is we'll buffer this cloud of points based on the day value. So in this example, I'm going to buffer each point by a small distance of 2 meters, and then I'll dissolve based on day, and then just OK. So the result is a polygon representing the area within 2 meters for all the points from August 11th, 12th, 13th, 14th, 15th, 16th, and August 8th and 9th. Then we can use the split tool to make individual daily feature classes for our hotspots. Okay, so the split tool will take our input points, and then based on whatever buffer polygon the point is sitting in, that will become the field that it's going to use to name the output points. So for example, all the points that are sitting in August 8th will become named August 8th, and all the points that are sitting in the buffer for August 9th would be named August 9th. And then we'll put them in a new target workspace. So I simply made a new file geodatabase called daily hotspots. So I'm going to add that as a container. So all these daily feature classes will be put in this new geodatabase called daily hotspots. And then just OK. So that gives us, for each day when we had a sample size above 10, we now have a daily feature class layer of those hotspots from each day. So now what we're going to do is, for each day, we'll delineate a polygon around these daily hotspots. Okay, so the first step is we're going to create a kernel density based on these hotspots from every day. So if you right mouse click on kernel density and go to batch, our input will be our first daily layer, so August 8th, and the output will go to the same geodatabase. And we'll call this raster August 8th. And then the cell size, we'll give it a cell size of 100 meters for our output raster. And then a search radius will be, for every pixel, go out 1,000 meters and find all the hotspots within 1,000 meters. And then we want to do this for every day, so then we'll just copy this cell, and then the next cell will be for August 9th. And then the output will be August 9th rather than August 8th. And then just repeat the process for all the daily feature classes. So we have August 8th, August 9th, 11th, 12th, 13th, 14th, 15th, and 16th. And then we'll have our output rasters corresponding to those days. And each output raster will be 100 meter pixels. And then for each pixel, it's going to search a neighborhood of 1,000 meters out and find all the hotspot points within 1,000 meter search radius for each pixel. And then our output units will be square kilometers. So this will be the density of points in count per square kilometers. But before we say OK, we need to set the processing extent. So if you go to Environment Settings for the tool, set the processing extent to be the same as our cloud of points. So as same as, the extent will be the same as the layer or Mississippi Fire hotspots. And that way our output rasters will all have the exact same extent, which is the extent of the cloud of our hotspot points. And then just OK and OK. So here's the kernel density raster for August 8th, for example. And here's the kernel density raster for August 16th. So now what we want to do is select all those cells that have a relatively high kernel density value and turn them into a 1, and otherwise make the cells that have a low kernel density value 0. And we'll use a threshold of 0.5 and we'll run the con tool in batch mode. So our question will be, is the pixel value greater than 0.5? And if that's true, return a 1. And we'll output that 1 to a geodatabase raster called Hot Raster August 8th. And then our input raster is, in this example, our kernel density for August 8th. And then we repeat the process for each daily kernel density raster. So basically we have our kernel density raster August 8th, 9th, 11th, 12th, 13th, 14th, 15th, and 16th. And the question will be, is the pixel value above 0.5? And if that's true, return a 1. If it's false, return no data. So then we'll have hotspot raster for August 8th through August 16th, and then just OK. So for example, here are the hotspots from August 8th, and here's the hot raster from August 8th, where everything in yellow is a pixel with a value of 1. So now what we're going to do is take those pixels that are a value 1 and convert them into polygons using the raster to polygon tool in batch mode. So for example, take our hot raster from August 8th, convert it to a polygon called hot polygon August 8th.shp, and simplify that polygon. And then we'll do the same thing for each raster. So for example, the next one will be hot raster August 9th. And then the output will be a shapefile August 9th. So when we're done, we'll have polygons of hotspot areas from August 8th, 9th, 11th, 12th, 13th, 14th, 15th, and 16th, and then OK. So for example, here are original hotspots from August 8th, and here's the polygon we are going to use to represent the area that had hotspots in August 8th, all the way to August 16th. So here are the hotspots from August 16th, and here's the polygon used to represent that area of hotspots from August 16th. Okay, so if you go to the Blackboard website, I've got some quiz questions for you on this exercise that will lead you to the next video session.